In this module, we are going to talk about how to perform integrations by using integral table. Before we go into the details of the integral table, we first ask a few simple questions. How do you perform the integrations for the functions as shown in these slides? In the previous module, we have discussed various techniques to perform integrations on the integrands of different sort. The techniques of integration that we mentioned in the previous modules only applies to integrands that assume certain specific form. For more general form of integrands, such as the one that is seen here, or this function, the integrations can be performed by not referring to lengthy numerical techniques, but it could be easily performed based on the collections of results that has already been proven in the form of tables of integrals. What is shown on the screen here is the collections of known integral results. The results of the integral that is listed in the table are obtained from various methods. In many instances, the results of the integrations are obtained by first knowing the differentiations of a certain function. By knowing the differentiation of a certain function, then the integral of the differentiated function can be obtained. That is the most common way of obtaining the integral results listed in the integral table. Other than the basic forms of integral that are listed in this slide, there are many other integral results that are not so easy to arrive at. It is not a usual practice in the teaching of calculus to derive all these integration results in detail, for the very simple reasons that the numbers of possible integration are almost infinite. People have compiled the results of certain well-known integrand functions that they think are common. They compile these results into the form of this integral table so that people can use it and refer to this table to obtain the analytical expressions of certain integral that assume some specific forms listed in this table. For example, the tables provides the integration results of functions that involve the expression of x squared minus a squared, be the expression appeared in either the denominator of the integrand or in the numerator of the integrand, or it's raised to some power, or is integrated along with an additional factors of x or x squared, either in the numerator or the denominator. The collections of the integral in this integral table could then be a source of reference if you encountered complicated integrations that could not be obtained by using the usual integration technique mentioned in the previous module. We will be showing you the easy way of obtaining the explicit expression for the 5 integrals as listed on the screen here. We will do this by making use of the formula that has been compiled in this integrals table. After we have gone through this module, you will become familiarized with the method of referring to the integral table to obtain the explicit expression of the integral that cannot be solved using standard integration techniques discussed in previous modules. Before we begin to use the integral table, it will be a good idea to have a quick look at the tables. The first part of the table provides the result of integration for some commonly seen functions, such as a constant function, some basic trigonometric functions, exponential function, hyperbolic cos, and a few more other integration results that involve the expression of a squared and x squared in various combinations in the denominator. These sections of the integral table provides the integral results for functions involve the expression of ax plus b. This part of the integral table provides the integral results for functions that involve the expressions of a squared plus x squared. This part of the integral table provides the integral for functions involving a squared minus x squared. This part of the integral table provides the solution of the integrations for functions involving x squared minus a squared. These sections of the integral table provide the solution for functions that involve trigonometric functions or the combinations of them. There are all sorts of different solutions to various types of trigonometric functions. This part of the integral table provides the integrations that involve inverse trigonometric function, and this part of the integral table provides the integral for functions in the form of exponents and natural logarithm. This part of the integral table provides a solution to functions that involve the expressions of square root of 2ax minus x squared. And here is the part of the integration table that provides the solutions to the integration involving hyperbolic functions. The brief tables of integrals as provided here is by no means exhaustive, meaning that there are many other integrals that could also be possible but not included in this table. A more complete solutions to the analytical expressions of more complicated integrand could be found in other internet resources. However, the integral table that is provided here could be possibly sufficient for most of the integral you encounter in an usual calculus class. As a summary to this video, we have just briefly reviewed and discussed in general what the integral tables is for. In the next video, we are going to show with concrete examples how the integral tables are used for performing integrations on integrand functions that cannot be integrated using the techniques we have discussed so far.